Hello, welcome to lecture 5, Quadrilaterals continued, that is from my previous lecture. So today I am going to present some exercises. This is mathematics for class 9 based on NCERT syllabus. My name is Sangam Banerjee and my details are given below. Today I am going to deal with examples and some exercises. So this is example 8.2 of chapter 8. Show that diagonals of a rhombus are perpendicular to each other. By definition of a rhombus, that all side has to be equal. AB is equal to BC equal to CD because it is a rhombus. And we know that if by earlier theorem which we have proved that the diagonals of a rhombus bisect each other. That means if it cross, it will bisect. This side will be equal to this side and this side will be equal to this side. So this is also given in theorem. So now we know that these sides are all equal, this 3 dash and this 2 dash is the half the diagonal, it bisects, and this single dash is half the diagonal which bisects, okay, DO and OB is same. So we know from side, this triangle DOA and DOC, okay, or AOD and COD, they are congruent from side, congruence rule. So since they are congruent, angle AOD will be, this is AOD, will be COD because it is congruent. But we know that this is a straight line, so sum of them has to be, this angle plus this angle has to be 180, okay, but they are equal. So that means this angle AOD, which is equal to COD, is equal to 90 degrees. This is 90, this is 90. So diagonal for rhombus are perpendicular to each other. So they are perpendicular to each other. Another example, show that the bisector of an angle of a parallelogram, bisectors, these are bisectors, means if this is the angle, I bisect the angle. So this is a bisector. So show that bisector angles of a parallelogram form a rectangle. Suppose I have a bisector here, I extend it. I have a bisector here, I extend it. I have a bisector and I extend it. I have a bisector and I extend it. So it will enclose one rectangle. Show that this forms a rectangle. So what we have to show that this angle between them are 90 degree. Okay. So if their angle between them are 90 degree, then it is a rectangle. So it is very easy to show. See, take this triangle. Okay. So see, this is a complementary angle D and angle A, they are supplementary. Sometimes I make mistake saying complementary and supplementary. Supplementary means angle, two angles when you add, they become 180. So this angle and this angle together, if you add angle D plus angle A is 180. Okay. So half of this angle A and half of angle D will be 90. So sum of internal angle of a triangle should be 180. So if this 2 adds up to 90, this has to be 90. So this is 90. So opposite angle, this is also 90. So similarly here also, these are the supplementary angles. Half of them, this is 180. This plus this is 180. So half of this and half of this will be 90. So this has to be 90. Sum of internal angle of a triangle is. So then opposite angle is 90. And similarly, you take a big, this triangle. Again, it is the same thing, you can use it. Okay, this is a parallel line, so this will be now the supplementary angle. So this and this is, if you add 180 divided by 2, this is 90, so this has to be 90. Similarly, you take this triangle and again same, this is 90, these two are added up, you get 90. Because these are the supplementary angle, half of that you are taking. So this is 90. This is 90. Okay. So you can show that S is 90, Q is 90 degree, R is 90 and P. So here I have written it down. Angle A plus angle D, this angle A plus angle D is 180. Same side of the traversal, that is supplementary. Divide by 2, I get 90. Okay. So DSA is 90 from sum of the angles, because sum of the internal angles is 90. So similarly PSR Okay, PSR, if this is 90, so this is 90. So similarly, you go about doing for the rest. Here I have written for the rest. Okay, same thing I have written for angle B plus angle C is, that is angle B plus angle C is 180 degree. So again I divide by 2 because these are bisectors. So when you divide by 2 is 90. The remaining one has to be 90 to make it 180. In sum of all internal angle of a triangle is 180. So what I have said, I have written it down. So you just pause, okay, freeze the screen, and you see what I have written. In next exercise 8.1.9, in a parallelogram ABCD, okay, this is a parallelogram ABCD, P and Q are taken on a diagonal. This P and Q are taken on its diagonals, such that DP, this length, equal to this length, okay, BQ. PD or DP is equal to QB or BQ. You can write it in any ways. They are equal, okay. So what are given, you have given this is equal, this is equal. Then you join this line here, okay. Let us try to understand the figure, okay. So we have to prove this APD, this shaded triangle, is equal to this shaded triangle. So this is given, and then I know that this alternate interior angle has to be same. This is a parallel line, so this angle. So I have this, and I have side, I have angle, and since this is a parallelogram, I know this side is equal to this side. So this triangle is congruent to this triangle. So first one is proved. Since they are congruent, again from corresponding part of congruent triangle CPCT, this side will be equal to this side. This side is given here double dash, this side is given here single dash. So this is the remaining side. So this AP is equal to CQ. So this also we can prove. And similarly we can prove triangle AQB is equal to CPD. How? Again I have this, okay. I can show that this angle, take this as a parallel, okay. Then I have this angle, so I have this angle, I have this side angle, side. Similarly side, this angle, side, and for this also side, then this angle will be same. This is the internal angle of this parallel line, alternate interior angle, this will be same. So side angles, and this side is same because it is a parallelogram. By definition it has to be same length. Parallel lines are of equal length. So this triangle is congruent. So this also we prove. And since this triangle is congruent to this triangle, then AQ is equal to CP. So this point is also proved. So since this and these two opposite lines have equal length, and this we have shown is have equal length, so then it is a parallelogram. So here we have proved it. Should I go? Okay, maybe I'll go for your sake. This PD, this is given, okay. PD is equal to QB, side is given. Angle I have written here, PDA is equal to angle QBC. This PDA, as I said, okay, internal alternate internal angle. So this is a corresponding angle, and this BC equal to AD, BC is equal to AD, this is also given. So from side angle side I can prove the first one. So similarly, as I said here, that because this is congruent, then from side AP is equal to CQ, which I said the remaining one will be same because this is given congruent. So this and this will be same. Third one, proof to similar, which I have shown, similar to 2. And in fourth one is also similar to this third one. Third one is similar to 1, and this fourth one is similar to 2. And in parallelogram, opposite sides are equal, therefore APCQ is parallelogram. Okay. Now theorem 8.9, the line segment joining the midpoints of two sides of a triangle is parallel to the third side. What it says? the line segment joining midpoint, this is of two sides of a triangle. Suppose I take this side and this is a triangle. A, B, C is a triangle. Midpoint of one side and the other side, two sides. So if I join, okay, then this side, the third side, this is the third side will be parallel to FE. Okay, if I join from this arm of the triangle to this one arm, okay, or if I join say from here to say somewhere midpoint of here, so this line will be parallel to this. Now I have done, you can rotate and do it, it's same thing. Okay, you can understand, no? This is the midpoint, and the midpoint from here you draw, this line will be parallel to this. This is what the theorem says. Okay, this sometime is given as an example or exercise also, so that's why I have put it here. So here triangle, so how, let us not go into this, let us try to understand this. So you draw one parallel line here to this one, okay, this arm of the triangle, you draw one parallel and make it a parallelogram. That you can always do it. Draw a traverser, this angle and this angle will be same, okay, and if I have a parallel line here and here, so this is a traverser, then this angle from the traverser to this parallel line and here alternate interior angle, they will be same, or this is cross, okay, so opposite angles are equal. So from angle side angle, okay, from angle side angle, these triangles are congruent. Okay, once they are congruent, that means since this side is equal to this side equal to this side, so this side also has to be this side. So now you get this parallelogram, okay, and by definition of a parallelogram, opposite angle has to be equal, so this angle and this angle is same, okay. Similarly, I can show that this angle is equal to this angle, so this forms a parallelogram, okay. So that means since it forms a parallelogram, so this FE is parallel to BC, okay. So what we have done here, anyway, this step is not required maybe. Given AE is equal to EC, AE equal to EC, and AF is equal to FB. This is given in the theorem. So from angle side angle, which I have told here, from angle side angle, okay, triangle, this triangle is congruent to CED, this triangle. So CD is equal to BF, CD is equal to BF, okay, because this side is equal to this side, but this side is equal to this side, so CD is equal to BF. Whatever I have said, I have written here. FE is equal to ED, FE equal to ED, which we have seen. So FDBC is a parallelogram, so FE is parallel to, okay, this is a line just extending, okay, this FD is an extension of FE, so FE will be parallel to BC. Okay. 8.10, the line drawn through the midpoint of one side of a triangle parallel to the other side bisect the third side. So this is the same thing, that what it is telling, line drawn through the midpoint of one side, okay, and it's parallel. So if it is parallel, it will cut at this point E will be the midpoint of AC. So this is the same thing. You just rearrange and you can always do it. And I think you should try to do it yourself. Okay. I'm not doing everything spoon fitting that you just go through it and you will not work at home. So you have to work this in half an hour. You cannot learn all the quadrilaterals. So you have to read many times and go through many other examples. I'm just giving you basic understanding so that you can tackle the subject more easily. Okay, now we go to exercise 8.2.7. This is also a simple example. Most of the examples in the books are simple. I have taken which I felt is slightly difficult. I have just taken it. So triangle ABC is a triangle, is a right angle triangle. That means this is 90 degree at C. A line through the midpoint M, this is the midpoint of AB, midpoint of hypotenuse AB, and parallel to BC, intersects AC at D. Okay, show that D is the midpoint. It is an extension of that theorem which we did, theorem 8.10, an extension of theorem 8.10. MD is perpendicular to AC. Of course, you are saying this is perpendicular, I am drawing a parallel, so this has to be perpendicular. If this is 90 degree, this also has to be 90 degree. And then it is asked that, okay, CM, this distance CM is equal to MA, and this CM is half of AB. Okay, so we know that MA is a half of AB, and if we can show that this triangle and this triangle are congruent, then my job is done. Okay, if I can show that AM is equal to CM. So since they are congruent, this common side, then this angle, this side, from side angle side, and again from side angle side, okay, I can say that ADM, triangle ADM is congruent to CDM. So AM has to be this from the CPCT. Okay, so this is what I have written. Solution, use theorem 8.10. You have to write, you have to show the steps. Okay, I am writing here use theorem 8.10 means you have to show you use those steps. And then second is CB is perpendicular to AC. Okay, because MD is parallel to BC. MD is parallel to BC. MD implies MD is perpendicular to AC too. And from side angle side, CM is equal to M. What I said, this triangle is congruent to this. So it is half. Okay, next exercise. Show that diagonals of a square are equal and bisect each other at right angle. Okay, diagonals of a square, these are the diagonals, they are equal and they bisect, okay, each other, and at the same time they are right angle. Okay, so we can show this also, like this is, say given this is a square, ABCD is a square. See here also you can use your intelligence to show that, okay, this triangle is congruent to this triangle. Why this triangle is congruent to this triangle? Because this is 90 degree, this is, is a bisector. Okay, these are the bisector. So this angle is equal to this angle. So from angle, side, angle, this triangle is equal to this. So then by CPCT I will say that this is bisecting. Okay, this OC is equal to OA. That also I can say. So you see how you would like to do it. There is not only one way. Every different students may have different style of proving the thing. So I am giving you one of the style. Okay, say given ABCD is a square, and we know that AC, we have to prove that AC, this diagonal AC is equal to BD, and OA is equal to OC, and OB is equal to OD. This we have to prove. So just now I said how to prove it, but anyway, let us go. So if triangle BAD, in triangle BAD, this is, say I take a common side. I take a BAD and CAD. Okay, AD is common. Okay, so once I take, I get two of the diagonals here in one go. So then I say, okay, from side angle side, okay, and from here side angle side, I can say triangle BAD and triangle CAD are equal. So since they are congruent, equal, sometimes I see this triangle are congruent. So from CPCT, this diagonal and this diagonal has to be same, because these are same, this is same. So the remaining one is this diagonal and this diagonal. So they also has to be same. Okay. So side is AD is common. I have taken AB for this triangle BAD, AB, is equal to CD is equal to CD, and angle A, this angle A is equal to angle D. So from side angle side, triangle BAD is equal to congruent to triangle CAD, and that's why BD, this hypotenuse, they are same. Okay, because square is a parallelogram, in a parallelogram diagonal bisect each other. So since they bisect each other, we have shown earlier also OA equal to OC and OB equal to OD. Okay, and in triangle AOB, this triangle, as I was saying, and triangle COB, okay, this AB equal to BC because it is a square, OB is equal to OB. Same thing I am trying to show here, that these two triangles are congruent. Okay, and OA is equal to OC. Okay, OA equal to OC because they are bisecting each other, which is proved earlier. So from side rule, this side rule, I can say that triangle AOB is equal to congruent to triangle COB. So angle AOB is equal to angle COB, this angle, which I was saying in the beginning, okay, is COB. So from linear pair of the angle, so this is linear pair, this and this is a straight line. So they has to be, since sum of them has to be 180 and they are equal, so this has to be perpendicular. So this not only bisect, but they are perpendicular bisector. The diagonals of a square are perpendicular bisector. Okay, so this is what we have proved here. Okay, each other at right angle, bisect each other at right angle. So now let us summarize what we have done in quadrilateral in the last two lectures. This is your chapter 8. 8.7 is the summary section. So in this chapter you have studied following points. Sum of the angles of quadrilateral is 360. In the previous class we saw it, not this, the just previous one, lecture 4. The diagonal of a parallelogram divides it into two congruent triangles, which we have seen. In a parallelogram, opposite sides are equal by definition. Opposite angles are equal again by definition. Diagonals bisect each other. That also we have seen. Okay, here which is written. A quadrilateral is a parallelogram if opposite sides are equal. Okay. If you show that opposite sides are equal, then it is a parallelogram. If you show that opposite angles are equal, then it is a parallelogram. If you can show that diagonal bisect each other, then it is a parallelogram. Or if you can show a pair of opposite side is equal and parallel, okay, then also it is a parallelogram. Diagonals of a rectangle bisect each other and are equal. Okay, so if they bisect, the diagonals bisect means divides into two, and they are equal, they are same. Okay, they are equal, or vice versa. Diagonals of rhombus bisect each other at right angles, and vice versa. Okay, for if it is a right angle, and if then it forms a rhombus, but there are conditions for rhombus. Okay, that all the angles are not same. If all the angles are same and it bisect at right angle, then it is a square. Okay. By now you should be expert in such thing. Go back and forth. You have a lot of time. This half an hour lecture you should try to understand. Work it for more half an hour or 1 hour extra to go back and forth. Diagonals of a square bisect each other. What I said, diagonals of a square bisect each other at right angles and are equal, and vice versa. The line segment joining midpoint of any two sides. The line segment joining the midpoint of any two sides of a triangle is parallel to the third side and is half of it. We have proved it today. Okay, the midpoint of one side of a triangle, if you connect to the midpoint of the other side, second side, the third side will be parallel. Okay, you try to do it in all orientation. You will see it. Take a graph paper and kindly practice it so that you will not forget. a line through the midpoint of a side of a triangle parallel to another side bisect the third side. Of course, this is the similar thing, that if you take from midpoint of one side, draw a parallel line to the some other side, okay, so it will bisect the third side, okay. You go through it, we have done this today. The quadrilateral formed by joining midpoint of the sides of a quadrilateral in order is a parallelogram. This also we have done today. A similar one we have done today. We have done this. So there in the last point it says that if you join this midpoint here, okay, of a parallelogram, they will also become. You just try to do it, okay, yourself. It is also simple. So that is all for today's class. Thank you. See you in the next lecture.